I'm John Crossland with Soilworks, California. Behind me is our advanced ripping equipment, the technology for which we've worked over the last 10 years to develop.
The purpose of vineyard ripping is to provide a uniform seedbed for even ripening of fruit. The Vibrosoiler creates 4 to 5 times the work soil volume of a standard ripper, allowing larger root systems. Growers should start with a detailed soil survey. Using this information, we can produce a soil amelioration plan allowing soil-specific earthworks and ameliorants to be translated to the ground. With a detailed soil survey, we can tailor our soil amelioration to the specific soil types.
Soilworks Vibrosoiler, a parabolic curve ripper with a vibrating wing keel. We can make the wing can move it up to about twice a second. We've worked out about one vibration every 750 mils or so is about right for profile mixing, or in a stationary position for maximum breakout where mixing is not necessary. The advantages of the Vibrosoiler over a standard D9 ripper are parabolic curve ripper. So the point is well ahead of the tine so that we break the soil before the tine passes through it, thereby reducing a compaction effect of the tine passing through the soil. The angle of entry is very low. The standard bulldozer at ripping depths of over about 450 mils will compact under the point or glaze regardless of soil moisture conditions, because the shear forces are just too great at that sharp angle. With a shallower angle, it allows us to rip to a deeper depths with reduced soil compaction under the point. The wings that we use here are about 500 mil wide and orientated in both planes. This gives us a larger U-shaped breakout. With the wing moving, it's always changing its shear planes so we don't have the glazing effect under the wing. The ram activation, which is linked to our ground speed radar, is capable of about 22 tonnes of soil lift. So we have a heaving effect as it goes forward, increasing the breakout. It's pretty general for us to have a soil bow wave or breakout out to about the centre of the tracks, which is approximately 2.5 metres or so. The operating depth is up to about 1.2 metres of deep ripping. For depths below about 800 mils, we generally rip in 2 passes, because ripping at those deeper depths in 1 pass will create some compaction because of the soil fracturing in front. The tractor that we've chosen is a Caterpillar Challenger, high horsepower, rubber belted tractor. The reason for the rubber belts is the low ground compaction with this type of unit, which is designed to pull only. With the wide 30-inch belts, we have a very low ground compaction of about 7 psi, compared to a plate dozer, a D8R for example, of about 28 psi. So it's roughly about a quarter of the ground compaction, about the same as your vineyard tractor. The RTK real-time Trimble GPS Soilworks uses is accurate to 20 mils, roughly 2/3 of an inch, and of surveyor grade. Utilising this GPS, there's reduced need for surveying, with only really your surveyor being required to mark out boundary corner positions. Soilworks takes it from there. We can also perform functions such as logging of the area, printed maps of block layout, and with our prescription map we can vary the amelioration and ripping depths as required across a block in real time from soil maps. This is our Soilworks large mounder, specifically designed for both orchard and vineyard applications. The unit offers us great flexibility with the ability to spread fertiliser either in behind the tine for deep fertiliser placement or into the mound top to be worked in by the discs, or alternatively out the back as well. We can carry around 4 tonnes of fertiliser on a belt spreader, which allows for spreading anything from compost to cow manures right through to gypsum and lime. Integral to this are our 11'6" grader blades, which can allow, just in a non-mounding situation with a disc only finish, the grader blades will only just run on top of the ground, maybe half an inch above, just taking out the lumps and bumps and tidying up. In a mounding type situation, the blades can take anything from half an inch up to 4 inches of topsoil, bringing all the topsoil and organic matter into a planting bed. And now to the business end of the mounder. As it is here, set up for vineyards or the first pass in the orchard mounding type system. As you can see, we've got a fair old rake of the blades, which allows for the soil to come in, and then with our crumble roller set, we can then top the bed of the mound into a nice crest or a flat top. And our latest innovation, the fertiliser spinners, utilised for spreading cereal seed cover crops in the last pass of an orchard mounding system or in a vineyard mounding system.
With our ongoing research and development, our Mark III Vibrosoiler, here shown with 3 tines and blade mounder. When fitted to our 485 horsepower new Challenger, we can effectively rip to 4 feet in any soil conditions. All Soilworks tools are manufactured from hardened steel to quality standards, built to last, utilising standard bearings where possible. Our tools range from establishment, ripping and mounding, right through to mid-row ripping down to 4 feet centres.
Well, soil moisture content is probably the most important physical aspect determining the quality of any ripping job. Soils behave dramatically different in a mechanical sense depending upon whether they're wet or moist or dry. The ideal moisture content to rip a soil is what's called the blower plastic limit, where the soil mechanical behaviour is just changing from brittle fracturing when the ripper moves through it, changing just to plastic failure. If it's wetter than that when you rip it, then the failure is all plastic and the soil remolds itself and doesn't fracture properly. If the soil is drier than the plastic limit, then the soil fractures in a brittle way, explosively, producing a lot of powder and a lot of dust. Our soil that's been ripped too dry is powdery, and over time, and sometimes over a very short period of time, like 1 year, the powder will weld itself together when it's wetted for the first time or the second time during the winter. and the soil will revert very quickly back to its former compact state. And that's simply because the fine powder has a lot of contact points, and the water content, the water from the rainfall, can act on those contact points to weld the soil particles back together. Soils that are ripped at the plastic limit, however, are not all powder. They have a range of particle sizes after ripping, and there's a probability with a large range in particle size that welding will be much less likely, and in fact that retards coalescence and keeps the soil porous and open for a longer period of time, which allows the vine to develop a fine, dense root system and become efficient at extracting water and nutrients from the soil. Whereas vines planted in powdered soil produce a thick, coarse, widely spaced root system that is very inefficient at extracting water and nutrients. Soil ripped much above the plastic limit when it's wet just remolds and repacks itself, and is really a very poor way of dealing with soil.
I'm standing in what we call our Delft pass of a two-pass system with the Vibrosoiler ripper. In this pass, after the soil survey has determined the total soil volume to be worked, taking into account the water holding capacity of the soil, the rootstock that the grower is going to use for his grapevines, and the goal for size of vine and quality here. We've set the ripping depth and the total workout, made this delving pass, and the next pass will be with a spreader truck that will put in 10 tons per acre of organic compost into the plant row, and then we will follow with our Vibrosoiler with disc following that will mix the compost with the soil structure and leave the bed ready to plant. Hi, my name is John Crossland with Soilworks, California. I'm in a olive orchard development that'll be high density close planting in Madeira. We've got San Joaquin loam soils that we're utilizing the Soilworks Vibrosoiler on a two-pass system. In these two passes we rip and then incorporate organic matter that's been spread in between passes and form the berm that the trees will be planted on.
I'm Steve here. I'm with Soilworks California, and we're here in Madeira, California, working on a future high-density olive orchard development. And just want to show you our technology of the winged Vibrosoiler. This is the San Joaquin series soil, which is also our California state soil. It's very extensive throughout the Central Valley, and generally speaking, it's a fine sandy loam, and anywhere from 24 inches of depth, you hit a very hard silica cemented hardpan. The thickness of that hardpan can range considerably from 6 inches to a few feet thick, and so it's definitely a root impenetrable layer. This is our wing in the down position. In the down position, we typically get a larger horizontal break. Here we're at 53 inches at the top of soil surface, and we have it to a depth of approximately 3 feet. Okay, here's on the other side, on the opposite side of the soil pit. This is the wing in the up position, and here I would expect to get slightly less horizontal break. No, it's actually about the same. We're still about 53, 54 inches. And depth is pretty much the same, about 3 feet. This is a two-pass system. The first pass we had the we had the shank at about 3.5 feet was what we were trying for without the wing, and that was just to shatter that hard pan. I want to illustrate the hard pan. Here is within our ripping area, our affected area. You can see there's still bits of the hard pan, but it's actually broken up. Well, that one's not too broken. Yep, it's broken up. Whereas here, just below our shank, you can see how hard it is. You can see it here as well, how much harder that is. So what we've efficiently done is broken that into smaller. We've broken that very hard interface between the fine sandy loam and the silica hard pan. We've broken into smaller rock sizes, if you will, which now have cracks, and the roots can penetrate between those cracks. Coming through on the second pass, we then blend, we put the wing on it, and it would blend the profile even more, and then subsequently further shatter that silica hard pan. So overall, your effective rooting area went from approximately 12 inches here to hard pan to 3 feet.
Well, I agree with Steve that it's a very limiting soil. This hard pan makes it unfarmable virtually without rupturing, and it's a root impediment issue, a low vigor in the vine, and in an area where vines need quite a lot of vigor because of the dry climate. But the ripping has in fact transformed the soil from a very low quality soil to something quite reasonable. Probably the most significant improvement for the farmer is that ripping this soil will have increased the water use efficiency of the vines or even the olive trees very, very significantly.
That's out of ripping interest and somewhere here because ripping goes there. Originally topsoil, that part more bleached, compacted horizon, quite compacted fly underneath. So what we did with the vibrating foot, we wanted to mix this layer which is suffering water logging under natural rainfall and therefore creating possible diseases and problems with aeration somewhere here and water doesn't get down there. We brought that one, brought it to the surface because I can show you right here to the surface bits and pieces of, I don't know, can you see it clearly, what it used to be, but there it comes there, including this, including that, this hard clay layer, which after breaking, it's quite easy to find it and to break it, has really mellows down and it is well mixed and brought more to the entire surface. So practically what we've done, we brought this layer somewhere there, mix it with the clay, and we break permanently that barrier between highly permeable and slowly permeable layer. Practically sterile layer and layer which is full of nutrients. So central ripping line should be roughly somewhere here. I'm just digging to that one to show that practically in continuity or in continuation, importantly this is where we at the same time brought surface soil which comes from somewhere there into the ripping line, and importantly, again importantly, no cavities, no breaking. That one is quite easy.
Soilworks 4-in-1 establishment system, ripping, disking, mounding and adding fertiliser all in the one pass. The grower here has saved time and money, but more importantly the results have been fantastic. With wire fill in 5 months on a double cordon and a good crop in the second year. He reckons it saves him about a year on vineyard establishment.
Here we are at Euston in New South Wales, typical mallee sort of country. The approach here is to first add approximately 15 to 20 tonnes of composted cow manure per hectare. And then what we do is we rip them out in one pass. And you can see here we're scalping about 25 35 centimetres, about 1 inch to 1.5 inches of soil, and building a planting bed here. The reason we do this is that in our shallow mallee soils, I think here there's approximately 20 centimetres on average of topsoil, and under that a limestoney type layer. So what we're doing here is we're incorporating all of the organic matter which is in the top inch or so into this beautiful planting bed.
This is really the first vineyard that we actually used the Vibra-Soiler on. It was planted in December 2 years ago, or 23 months ago. Soil was opened up. We put a delving mark in with the Vibra-Soiler. We just put the ripper in only about 300 or 400 millimetres, opened a delve up about 500 millimetres wide. We straddled it. We put the equivalent of 25 tonnes of composted organically certified cow manure into the delve. Then we added 1,000 kilograms to the hectare of phosphorus with zinc added into the delve. Then we double rip. We then went over with the Vibra-Soiler with the vibrator working, and we blended that soil and the fertiliser and the cow manure down to 750, 800 deep. The ripper was actually deeper than that. That's when you put the mounder on. The mounder's on the back of the Vibra-Soiler, just folds the soil back in and pours it back down behind the tine. And this is the result. This looks like a fully mature vineyard, and it's actually carrying. It's perfectly in balance. It's Chardonnay, and it's carrying probably 28 tonnes to the hectare in its first crop. It just gives you an idea of if with good soil preparation, good vines, you can end up with a result like this. We do all of our vines the same way now.
The optimum situation is to set up your vineyard sustainably from the beginning. This is obviously not a solution for most growers because the task at hand is to maintain existing plantings. However, it is useful to know the way Chalmers Vineyard has been established, as it helps to understand the way it is now maintained. The soil preparation begins with 25 cubic metres per hectare of certified organic composted cow manure and 1,000 kilograms per hectare of superphosphate plus zinc, which are applied to the bare earth in a concentrated 1 metre wide band along the vine row lines using GPS guided spreaders. Soil amelioration is